So, Vanakkam. So, we will continue our lecture on engineering seismology. So, last class we discussed about the seismogram. Basically, we talk about the oldest seismogram Sinoscope, how people have tried to understand that. So, finally, they figure it out that some kind of the pendulum, okay, the mass with suspended so inertial provision could able to measure a vibration. So, that is why we have understand. From there people have seen that there is a need for recording a 3 component of the vibration as the wave will respond for a particular vibration. For example, the P wave will be more dominantly reflected in the vertical component. So, the other component like the S wave and surface wave will be reflected in the horizontal component. So, the measuring of 3 components are very important. We also end up saying that a different type of waves created by the earthquake and its natural frequency or frequency band or range. So, which will help you if you want to measure the earthquake above 6, you should have the instrument which has that particular frequency, and if you want to measure earthquake above 2 and then what should be there, and above less than 2 what should be there. So, then if you want to measure the earth tide what should be there, this is what is. So, the type of equipment, okay, so the type of equipment and the minimum requirement for the equipment. So, all those things are very important to record a particular earthquake. Okay, so you can have the equipment such that it can record earthquake at anywhere in the world, or you can have the equipment such that you can record earthquake at near to your home or in your country or in your continent. So, depends upon the sensitivity and application, one has to choose a particular type of wave. Okay, so frequency range of the equipment, so where you can record a particular wave. So, the seismometer can be broadly classified based on its requirement and application. So, based on the period of record, okay, we can classify it as a short period and long period. So, the short period means the instrument sensitive to seismic wave that vibrates several times per second, called as a short period seismogram, are used for record local earthquakes during which the waves reaching the seismogram are still very rapid and close together. Some short period seismograms are magnify the ground motion several hundred times for the display and noting down the amplitude and all. So, basically these short period sensors are useful to record local earthquake. That means, if I have the short period seismic equipment installed at IISc, I could be able to only record earthquake which is happening in and around IISc or in and around Bangalore. I cannot record earthquake happened in the Delhi using the short period sensor installed at IISc. Okay. The similar way, the long period sensor, the long period seismogram respond to the lower frequencies waves that are used to record a distance. Even modern broadband seismogram perform both short period and long period function. So, for example, I want to record earthquake occurring at Delhi, my equipment should have the long period capacity. Okay, it should be low frequency, it should work. That is why long period you will get. So, that is how so based on the type of record, okay, the type of data what we record in the instrument, the instrument can be classified as a 3 major category. One is that strong motion instrument or accelerogram instrument or seismogram. So, record acceleration of the ground in terms of G value, that means it would record very high vibrations and record earthquake magnitude more than 3 and above. By post processing, velocity and displacement post Fourier spectrum can be obtained. So, if you want to record a high level earthquake vibration close to the source, you should have the strong motion record, particularly earthquake 3 and above. That means, if you have the strong motion instrument at a particular place, okay, if you are getting a local earthquake smaller in magnitude, you cannot record that in that particular instrument. Second, the weak motion instrument record events of magnitude less than 1 and record velocity in the function of velocity records. The earlier one is the function of acceleration. So, it record event that along a circle radius of 800 to 900 kilometer. This you should remember, the weak motions could be able to record a 800 to 900 kilometer and works in the range of 1 Hz frequency. The broadband seismometer record velocity can record event occurring anywhere in the world. Range time period of the instrument is 120 seconds. For your information, we have the seismometer at IISc, which is imported one. could record 120 meter second capacity and also weak motions and also strong motion. So, we have a 3 category of seismic instrument with us, which we will use it for the recording the some kind of signals. So, to more know about the strong motion accelerogram, in the case of large earthquake nearby, the ground motion may be exceed a recording capacity of the seismogram, basically velocity capacity of the seismogram. To record signals from large local earthquake, accordingly the third type low gain and strong motion seismogram is needed. Strong motion seismogram apply a minimal magnification less than 100x and are generally sensitive to the ground acceleration. A seismogram whose output is proportional to the ground acceleration is comparison to the usual seismogram, those outputs are proportional to the ground velocity. So, generally seismogram will record a ground velocity, accelerogram will record a acceleration. So, the accelerogram are typically used instrument designed to record very long ground motion, useful for engineering design. Seismogram commonly used to upscale these circumstances. Normally strong motion instrument do not record unless triggered by the strong motion signal. Okay, this is an option where you can define a cutoff level and it can be triggered. So, that we will see what is the trigger mode and continuous mode recording in the coming this one. The size as depends upon this character of the seismometer. So, one can go for the choice of seismometer depends upon the application. As I told that long period seismometer sensor if you want to use. So, it will be useful for in the range of frequency it should be 0.01 to 1 second or good recording for the distance earthquake. Short period will be covered in the range of 1 to 50 hertz. These are designed to record local earthquake. Broadband seismometers span the response spectrum covered by these two instruments. They provide complete seismic information from 0.01 hertz to 50 hertz and therefore allow much broader range of studies of SP record. They are relatively expensive, are used most for the research application. So, nowadays apart from these three there is one more called very broadband seismometer. So, it resolve lowest frequency resulting from the earth tide and the free oscillating of the earth. Their importance advantage of BB is their ability to record frequency below 001. Their primary purpose to research and deep interior of the earth. Data from VBB are very important and the international seismology community 1 or 2 such stations recommended for each country depending upon the area where it located. You can see the similar earthquake recorded by the different seismometer. You can see the short long period, short period and then the BBG equipment. So, similarly the signal for the different signal. You can see the amplitude and the recording time which makes a difference. So, you have to choose a proper instrument depends upon the your particular application. Okay. So, in the olden days basically this was recorded, all the earthquake was recorded in the analog. So, they have the mass and the inertial force balance system such that it can record vibration accordingly. So, the analog seismometer still working in some of the places, but not all the places. So, I am fortunate enough when I was doing my UG and like BTech or BE and ME degree. So, since I have interest on earthquake, I went to the meteorological observatory in Chennai where I could able to see the analog record earthquake recorder installed in the place where it was drawing a continuous line like this. So, it basically what I have seen, I just give the representation. So, basically there was a drum. So, it was like this is a earth tide. Okay. So, he says that there is no vibration, it is placed at Nungambakam in Chennai. I am not very sure where it is placed nearby. It goes like this. If there is a earthquake, then it will record like this. Okay. So, depends upon the wave, it will record and then it will come to the original position. So, this is how the wave getting recorded, where there is a pen, ink pen, or there is a pencil which is connected in the photographic paper, this was recorded. So, once you recorded this in the analog system, you will take this paper and try to place it on the graph sheet and try to identify how much the amplitude, what is the starting time, what is the end time, and from that you can estimate where is the earthquake origin. That is what we discussed in the last class. You could able to get the, if you know the average velocity of the region, you could able to get the origin point of the earthquake using this time difference. Okay, that is what is possible. So this has been widely installed most of the countries. Okay, so just to erase this part. So you can see here, so this is the typical analog recorder, portable in nature, where people can take this and see. You can see this is basically how this record. Okay, this is the record which you have to see here. So most of the English movie, when you see this, you might have seen this kind of old movies where you can see record. So similar kind of, this is a portable one, but there are permanent stations also installed. What I have seen in the Nungambakam is basically permanent station. So India, as per my knowledge, I am not very sure any how many analog system presently working, but most of them are the converted digital. But if you want to specifically see the analog system which is used olden days, you can visit IIT Roorkee Earthquake Engineering Department, where they have the showcase of this instrument in that location. When you had a chance to visit there, you can see this analog instrument, how this one. So this was the Milan version of the record. So where they start using the paper and magnetic tape, and then followed by the smoked paper, all those things ideas come. As we have seen that the music initially we used to see the disc based recording, followed by the cassette with the tape, then we come up with the CD. So now we are recording in the pen drive. Okay, so I am the generation, I have seen all of them. So those who are in my age and older than my age, they might have also seen all of them. Maybe the new generation who are studying +2 or degree, they may not seen the disc and tape recorder, but still it is available in if you want, you can go and see the many places. So in case if you had a chance to visit IISc, particularly when the open day is going on in the March time, you can see a different recording system used in the computer, like this magnetic digital and punch card and lot of things in the SCRC when the open day comes. So the later, after the electronic development has happened, the digital recorder system come into picture. So the digital recorder system made many things easy for the seismologist. As I told you that the hard copy of the recording, you have to take it, cut that paper and take it and put on the graph sheet and try to see how the amplitude time varies, but here such issues are not there. So you can get everything directly in the digital in terms of the count. Okay, it's the Holt count per time. Okay, how much Holt it is count. So basically you can also control this reading per the how many samples you can record per a time, that is sample per second. You can record 100 or 200 or 50 or 10, depends upon the storage available in the instrument and the data requirement. So this is basically reduces the manpower required for the analysis and the interpretation of the data, which is highly useful for the modern seismometer nowadays. So in the digital things come, so the people has to undergo some understanding about the seismic data. Okay, so what is that? One is that sample per second. So how many samples you can handle per second, that is one capacity you can. Second, depends upon that if the continuous recording and triggered mode recording, you should understand. Continuous recording means the seismic instrument can continuously record a data. Okay. So and store it, that is a continuous recording. Triggered mode means, so since if you want to avoid unnecessary signal, which is earth vibration or vehicle vibration recorded, you want to only focus on the earthquake, you can tell the seismometer, or you command seismometer using the digital computer program, okay, saying that I want to only record above this value of the count, okay, 0.001 G or 0.001 meter per second, something like that you can specify, so that you can record only the interesting earthquake record needed for the analysis, remaining we can discard. So this kind of trigger mode of operation or trigger mode of data acquisitions are predominantly used in the seismometers to avoid unnecessary delay. For example, the seismic station kept at a very remote place, okay, where there is not possible to go and access that frequently. So you can command that only record this earthquake, so that the storage will be maintained. But now because this was the case when the storage was a big problem, because when I do the undergraduate degree, the floppy usually used as a storage. So it has only that 15 MB or something like that. So but now we use a small pen drive which has a capacity of TBs. Okay, so terabyte data we could able to handle. So like that now the seismic storing system, electronic storing system capacity increased considerably. So nowadays this triggered or continuous mode is not too much save the storage space, but you should know that the seismometer is continuously monitoring. Only the recording decides a trigger mode. It is not off. Okay, the equipment is continuously working. Triggered mode means only it record the portion of the data which is exceeding the level will be stored as a file, remaining will not be stored. In the continuous mode everything will be stored. That is the difference between this one. So the continuous trigger mode also taken into account of the, so the ratio of the amplitude short average and long period average. So this is giving you the STA and LTA. So this gives the idea like what type of signal you want to record. Okay, you can specify this signal and you can specify the level of these values. Based on that you can get a record. So whenever you have chance to visit IISc, or you can mail me if you want to see this seismometer personally and know all those components, how it works and all. So you can explore, or you had a chance to see some other place also, we can arrange. So otherwise I will also see if there is a possibility that I can record a complete video of this and try to upload. So before ending of the course, I am not very sure, but let's see how it goes and all. So this is how the seismometer continuous and triggered mode operations are happening. So this helps, basically the digital recording allows to do much more quantitative analysis than the analog recording. The large dynamic range due to which the amplitude does not saturate in the case of large ground amplitude. So dynamic range is ratio of the largest to smallest input signal that system can measure without distortion. You can see the dynamic range and clipping level and lowest detectable noise level. So we using this you can get your dynamic range adjusted, accordingly you can record your store. So this is to store your data and disseminate and analyze the data. Okay, so you can also pick up your arrival point. Okay, so very accurately using the cursor. As you know that computer you can enhance and zoom and then play with the data in the digital platform. So that advantage, and also you can apply necessary filter very accurately to remove some of the noise which you find which is not a earthquake. For example, when earthquakes are occurring, there was a continuous noise in the region due to some operation of motor or something else, then you can avoid those kind of noise by applying a proper filter, which is possible in the digital and may not be possible in the analog that easily. So those are all the provision you get. Apart from that, as we told that the wave, okay, the wave pattern, wave arrival, okay, wave shape decides how many layers the waves are passed, how the source is, how the path is, okay, where the origin point, those are all called as a wavelet properties. So the digital record allow estimate wavelet parameter. Such parameter provide much deeper insight into the seismic source process, seismic moment release, the duration of the true ground displacement TW and rise time TR to maximize amplitude containing information, the size of the source, stress drop, which we have discussed last time, what is the stress drop, attenuation of the pulse propagating through earth, integrating over a area underneath displacement allows to determine a signal moment MS. So all those things are possible in the digital record, which is not possible in the analog record. This is a typical digital record where you can pick up each and every point useful information which will help to estimate the different wavelet parameters. Okay. So this about the equipment and digital record, analog record we have seen. So the next we are going to see a seismic station. So seismic station is the place where the seismometer housed or kept is called as a seismic station. So generally the seismic station should consist of the clock, okay, which is synchronized with the real time monitoring in the globe. Like for example, nowadays all the seismic station synchronized with the satellite, so that the time keep on updating universally, and there is a recorder and a sensor to detect a vibration happening, that collection of that and then storing the data. So these are all the minimum component any seismic station should have. So the clock and the coordinates with like a GPS coordinates with to communicating with the satellite, and then the recording system and storage device. So the individual station can provide interesting information about the occurrence of the earthquake. If you have the one station, you get the signal waves recorded. So it depends upon the expertise what you learned so far. You can say that there was a earthquake occurred at this place, this type of wave I recorded. Then further, if you look at the very closely the type of wave and arrival time, by chance if you have the P and S wave, then you can see that this is the radius I got a earthquake. Okay, this is my earthquake recorded at this radius from the station. That information can be obtained from the single station, but maintaining single station will not help to find out very accurately location of the station. So that is why the maintaining the seismic station, the multiple numbers are mandatory. There are 4 ways the seismic stations are maintained. One is the regional network, global network and seismic array. So we are going to discuss all of them now. So the regional network typically consists of tens to the occasionally hundred of seismic station spaced at the interval of 10 sub-kilometers. So this generally recorded kept in the regional level. For example, Bangalore region, there may be seismic station kept in and around Bangalore, that is called as a regional network. Monitoring the seismic activity within and surrounding the network are used to characterize a particular region. Regional network are often sensitive to the seismic event as small as magnitude 1 and less, and because their wide distribution can be used to determine very accuracy of the location and depth of the seismic event. Primarily uses the evaluation of the seismic hazard. They are useful for determining the earth structure, for recording the large distance earthquake and explosions. Because their focus on small to moderate earthquake to at regional distance, the instrument of regional network is tuned to higher frequency part of seismic spectrum where the regional waves are seen. In the past, regional network were run by the equipped with the single vertical component. Later, the single component equipment are destroyed, so they change it to the 3 sensor component, and many regional networks are in the 3 component. The another one is the global network. Global network traditionally been used to investigate the both interior of the earthquake phenomena that create a seismic signal such as earthquake and explosion. The global stations are designed to sensitive the seismic event anywhere in the world. That means the global network could capable of very broadband system record earthquake anywhere in the world. Global seismic stations have 3 component. So the one vertical, 2 horizontal. So optical geometry distribution station globally, so that even the earthquakes are occurring at the different place with stations on the shadows, and some other stations in the region can pick up. So that such that the global networks are this one. So this is especially used by the some of the countries for the nuclear monitoring phenomena, and also some blasting and other activities and all. So here I could share the interesting news. So you might have seen that whenever there is some kind of nuclear testing happened in the North Korea, immediately the US come to know, and then they say that you are tested nuclear this one. You know how? The global network. So basically, in the name of global network, a particular country or a group of scientists, they give a free installation of seismic meter to different countries. People thinking that, oh, we get money, we have to install this seismometer. It is not for your benefit. Basically, in the name of recording earthquake, they are also monitoring what is happening in your region. Okay. So even people try to make that not to happen by intelligence way. So one of the interesting story I can share here, that when Abdul Kalam was the scientist at ISRO, we tested a first nuclear explosion in the Rajasthan. So what they know, how they planned their activity, as you know that the US, basically NASA monitoring the entire globe using the remote sensing process of satellite scanning. Okay. So where they scan satellite, and when so basically testing up nuclear things, you have to move a large military force, because you have to drill deeper level like 1 kilometer, 2 kilometer, and then also you evacuate your people in that region, and that entire region should come to the control of army. Okay, then only you can decide what can be done in that particular location. So the moving of this kind of large army force and all will be scanned in the satellite scanning what is happening throughout the world. So what Abdul Kalam did actually, they have a sandstorm in the Rajasthan where the air mixed with the sand dust, you cannot see what is happening in the ground. So during that period, that 15 days, they moved everything and settled and drilled, and then they did a nuclear explosion test. Then because this global network, this explosion has been captured in the seismometer, immediately US come to know that okay, there was a explosion, it is happened in this place. Then they find out based on the signal how much explosion has been exploded. Based on that only they come to know that there was a nuclear testing happened in India. They asked India and put some ban. Finally our country also agreed that yes, we have done, that is we have done for our safety purpose. Okay, so these are the global network basically used for that kind of prime importance, not only understanding the earthquake. All the country, this kind of global network are known to government or unknown to government has been installed. Okay, that is the global network. So the another one is a seismic array. So the seismic array basically try to understand how these waves are changes with respect to the soil deposit in the smaller region. The cluster of seismometer distributed over a relatively small area, typically few kilometers across. Arrays improves detection of event at greater distance by being sensitive to the particular wave of a particular direction. So these are all used to understand how the wave amplifies, attenuates, and how the liquefaction occurs at particular region, which are the wave get reflected, amplified. Those kind of studies can be done in the this array kind of station. So this is the typical array which is maintained by the Smart 1 in Taiwan, where you can see that this is actually the dimension. So this is a 2 kilometer, means this is throughout is within like 10-20 kilometer. There is a station which is installed on the rock. Then again there is a deposit like our Indo-Gangetic basin where they installed several. You can see the same earthquake signal how it varies with the distance, and you can also relate with the inside soil how it varies. So this kind of understanding of amplification and soil wave character changing nature of the place, you can do this, which will help to design a building at this kind of region. Okay, so that is what this will be seismic array does. So basically this seismic station, combination of different seismic station, we can call it as a array, and then the regional network and global network. But this seismic station, before installing the seismic station, you should have some minimum requirement to fulfill that particular site is good for seismic hosting a seismic station. What are those requirements? There are various constraints in the site selection which affect a station distribution. The seismic noise is high, benefit of modern instrumentation lost. Because of the very sensitive, the noise will be always recorded and disturb data processing, and poor detection will result sometime. And if the stations are situated on the soft ground, even BB or broadband station or very broadband can record will be useless. The SP response will be not be irreversible. That means you should not choose your station at a soft ground. So inaccessible terrain and long bodies of water may be put serious constraint to reach station for maintenance and getting the data. So that should be avoided. Similar cultural noise near large cities, highway and any industries, all those places try to avoid, because that will create a vibration noises to the seismic radar which will be there. So predominant point is actually this may consider making the temporary micro. So offset office studies headquarters should be made, selecting potential site so that the safety of the equipment and then processing and all those things will be easy. So site should be easy to accessible and should be exposed to the properly to the sun and satellite signal, so that GPS coordinate and time updates are keep happening. These are all the criteria one can consider while selecting the seismic station. So in a given region, how many stations you should have? So there was some international discussion on that. So an effective micro earthquake network like permanent or temporary, which can be provide reliable data for the seismic earthquake location, station site should be eventually distributed by azimuth. So the maximum azimuth gap between the stations should be less than 180 degree. That means if you keep one station, so if you keep one station here, the another station should be within the 180 degree, means it should be somewhere here or here or here, here, like this, within the 180 degree of the azimuth between the stations. So the optimal distance between the two station, basically the optimal distance between the two station is basically decided based on the area of this one. So for example, if we take the area is A, the network approximately A by S2. The S2 is the station needed, where S is the station spacing. The earthquakes are concerned along the fault, total number of stations required could be less. So generally the station, the distance between the station S should be decided twice average focal depth of the earthquake. That means if you have the earthquake focal depth is 10 kilometer, so you should roughly have 20 kilometer as a distance, not very large distance. It will create a error in identifying the depth and the position of the earthquake, like epicenter location and the distance, which will cause us a error if you have the less number of station. Okay. So with this we close this lecture. So basically we understand how the seismometer is useful to record different signal, what is the minimum requirement, what are the different seismic network has been operated, what is the consequence of that, and then followed by we also understand what is the minimum station requirement for placing the equipment, and then setting up number of instrument, how it is done. So the regional network and then the global network and array kind of things. So as for India concern, we maintain regional network at only at Delhi, I think. So we, where the many stations are there close to Delhi. So then other places we have some station, but which is not fulfilling the requirement of this. So we will discuss the seismic instrumentation of India in the next class, so that when you collect any data from the IMD or the seismic recording agencies, you should know what is that limitation. You should know how accurate it is. For that it will help you. So with that we close this lecture. Thank you. So we will meet in the next class.